My name is Yasemin GÜNEY and I am a final year student of Hacettepe University Electronics Engineering Department. Me and my friend Serdar YURTCAN are working on Dr. Barış YÜKSEKKAYA's project Cell Association for Ultra-Dense Communication Networks. The structures and the talents of cells and base stations in cellular telecommunication systems that's now being used in today's world show some similarities. A base station with such structures functions as a transmitter in a big cell. In that case, an intercellular interference occurs and the users that are located in that region of interference which you face with disconnection problems. The heterogeneous network model is used to fix these disconnection problems. This model depends on the principle of enabling different base stations that are characterized by different talents and different coverage areas operate into a specific region. The goal of this structure to prevent the problems of communication and connection problems which users face. We observe the users connected to the base station through simulating them into random situation in MATLAB.
Hello, my name is Serdar YURTCAN. I am going to explain you the key points of the code section. First, we created a coordinate plane with the size of 500 to 500 meters communication area. And we put there a several number of users to create a multi-user network. The users are randomly separated into communication area and every user has its own channel coefficient. The number of users equaled 20, but this number is adjustable. After that, we added two different base stations. Their powers are adjustable too, but we set their power as a 43 dBm and 23 dBm for reality. We took their height as a 35 meters, which is average base station height. Then we made loss calculations. We took account of shadow loss and line of sight loss. We calculated these loss coefficients in reference to the TR 38.901 3GPP standards. We also considered that all the users' height were varying between 1.5 meters to 2 meters. Here is the algorithm that we used to find path loss and other coefficients. We created Freire channel coefficients. All users have different ratio of real and imaginary parts. This ratio determined randomly because every user has a different capability of connecting base station. After calculating all losses and channel coefficients, we found all of the users' signal-to-noise ratios for two different base stations, according to the given formula in the figure at the right side. After this calculation, all users decided to connect one of the base station, which has a higher signal-to-noise ratio. We will have a look at the simulation results later on. Now we take account of the interference which is caused by the other base station. We calculated signal-to-interference plus noise ratio according to the figure on the right side. When we consider SANR, users won't directly connect to the nearest base station, because the signal power of other base station may affect the user's connection quality. Let's check the simulation results to see this more clearly. But before that, these are the references of the figures that we used in this presentation.
When we look at the network simulation with only SNR comparison, we can see users select generally base stations that they are closest to. All users act like there is only one base station and it's the one which they are connected to. For example, user 7, user 8 and user 6 selects the base station 1 and user 1, user 19 and user 16 selects the base station 2 because they are closest to each other. But when we look at the more realistic SNR comparison, things are different. Users could select not only the closest base stations to them, but also others at the far. Because other base stations' presence may affect their connection qualities. So they want to connect other base station. For example, user 3 close to base station 1, but user 3 selects the base station 2 because of the interference. Okay, thank you for listening.